Hi guys, welcome to another episode of MrLopezClases.com. Now we are going to continue with the episode number 2 of chapter 3 in your book of marine electricity. This is the chapter dedicated to the batteries, and we are going to continue with the batteries, the marine batteries, the study of the cells. And in this episode we are going to check the procedure to verify the condition of the battery, and the procedure to check a battery if the battery is integrated in a group of batteries, and some tips and recommendations. Okay, don't forget, number one, before we continue, is that the batteries, if the batteries are lead batteries, lead acid, gel, or AgM, the recommendation is never discharge those batteries more than 50%. No more than 50%. And now we are going to check why this is the recommendation. Oh, Mr. Lopez, the lithium battery, they say that you can discharge completely. Okay, they say that it's possible to discharge those battery completely, and you can recover the battery, and the battery is not damaged. That's true, but I don't recommend discharge those battery more than 65-70%. And it's not because the battery, probably the battery is designed to support deep discharge. It's basically because it's hard, it spend too much time, the recovery process spend a lot of time. This is number one. And you need a lot of time and a lot of energy with the battery charger to recover the battery bank. This is not good. You want to recover the batteries as faster as possible, because you need the batteries in your boat, in the house battery bank, or in the inverter battery bank. Okay, the recommendation is never go down more than 65-70% in case of the lithium batteries. Later I'm going to explain that situation. Okay, we are going to continue checking the cells of the batteries, and I want to see that picture because that picture is interesting. A lot of people have the misconception about the voltage. What is a good voltage for my battery? And the people say, I have 12 volts. 12 volts is okay. But let me explain something about the 12 volts. Look at this. If the battery is 12.06, 12 volts, the battery in this moment is 50% discharged. In other words, if your battery is 12 volts, the battery is in the limit, 50%. Practically a little more and the battery is out. Oh wow, 12 volts is not a good indicator. What about 12.1? Okay, 12.1, 12.2 is 60% of charge. The battery is 40% discharged. Oh, that's not good. All right, the good battery is around 12.6, 12.7. When the level of charge in the battery is 12.6, 12.7, that indicated that the battery is 100% charged. What happened when the battery is 12.6, 12.7? How much is the value in charge of each cell? Is around 2.12. Oh, interesting. 2.12. What about if the battery is 12 volts? If the battery is 12 volts, the voltage in each cell is 2.0 volts, 2 volts. That indicates that the battery is 50% discharged. It's in the limit. It's not good. Be careful with that number. Now we are going to talk about the method and some tips about that situation. Okay, the battery banks, we talk about the battery banks recommended. We talk about the most common battery banks in a typical medium pleasure boat or pleasure yacht. The house, the cranking, the generator, the bow thruster, the electronics, and the inverter battery bank. Don't forget, all the negatives in the different group of batteries should be connected together, and they should be finishing in the negative bus bar, in the main negative bus bar in the engine room. Okay, and we talk about the plates and about the cells. The voltage in each cell is around normally 2.1, 2.2 volts. This is why if you connect in series 2.2 plus 2.2 plus 2.2, you have a 12.6, 12.7 volts in total. All right. This is the capacity of the batteries, and remember that you have two terminals. One terminal is pure lead, the negative terminal, and the other terminal that is eroded, that is sacrificed, will be oxide of lead, because the oxygen attack the metal and convert that piece of metal in oxide of lead. All right, and the electrolyte is a mixture of water and sulfuric acid in a proportion of 35%, and water, 65% of water in that mixture, in that electrolyte. Let me tell to you something about that situation in regarding the charging and the discharging mode. Is what about the recommendation to recover the level? Right now we are going to talk about that. This is the most important part, the electrolyte. The electrolyte is a mixture of water. The density of the water is 1,000 grams per cubic centimeter, and sulfuric acid, the density is 1,830 grams per cubic centimeter. What is the meaning of that? The acid is heavy in comparison with the water. The acid is heavy, okay, normally the acid will be in the down of the battery and the water will be on top of the battery. Interesting, no? Okay, and look at this. We are going to check, this picture is nice. This is the picture when the battery is discharged, completely discharged, and this is the picture when the battery is fully charged. We are going to analyze what happened with the acid and what happened with the water. Look at this. When the battery is fully charged, we have a minimum amount of water and a maximum amount of sulfuric acid in the electrolyte. When the battery is fully charged, the content in the electrolyte is more acid than water. And when the battery is completely discharged, we have in the electrolyte maximum water and minimum amount of sulfuric acid. And the $1,000,000 question is, where is going the acid when the battery is discharged? Okay, the acid will be impregnated in the plates of the cell. And the rest of the liquid in that moment, if the battery is completely discharged, will be water. Oh, interesting. Nice, no? And when the battery is fully charged, the electrolyte is basically pure acid and little amount of water. Completely opposite, no? Remember, in the process of discharge, the electrons are flowing from the positive terminal into the negative terminal. In the process of recharge, when you connect the battery charger, okay, the ions goes out from the negative terminal, from the cathode, enter in the electrolyte, and with the current, the electrons and the hydroxides are separated, and the electrons saturate again the anode. All right, this is the process of recharge, and this is the process of discharge. Don't forget that method. Okay, and what is the recommendation? Some people say, oh, I am checking the level of electrolyte in my battery this morning, and I found that the level of electrolyte is too down, practically disappeared the electrolyte. And normally the people say, okay, recover the level with the still water. Okay, the still water, of course, is better than fresh water, and of course is superior than salt water. Salt water is not good because salt water is a good conductor of electricity, and if you added salt water in the battery, you destroy the battery immediately. It's an excellent conductor and produce a short in between both plates. All right, that's not good. But the still water is good, but be careful with this. Suppose that the level of electrolyte is low, and you recover the level. Normally, what is the level recommended? A little over the plates. You see that when the electrolyte cover the plates and pass a little over, this is the level recommended. Some batteries, they have a special window to check the level of the electrolyte. That's better. Okay. What happened if you recover that level with a pure distilled water? What happened with the proportion water and acid? The proportion right now is 65-35? Probably no, because you added half of a gallon of water, pure water in the battery. And now the proportion is not 65-35. Probably the proportion right now is 90% water and 10% acid or something like this. And what happened with the battery? It's simple. When you try to recharge the battery with the battery charger, the battery don't reach the 100% of charge. The battery only reaches 70%, 75%. And the complaint of the customer is, I don't know what happened with my battery, but right now the battery never passed of 75, 80% of charge. the battery don't reach the full charge. You added recently water in your, yes, I added a gallon of distilled water. That was the problem. Right now you change the proportion of this. What you need to add it? You need to add it this electrolyte. Where can I buy the electrolyte? You need to buy the bottles of electrolyte in any storage dedicated to fabrication and reparation of batteries. You said I have this type of batteries, lead acid or gel, and you can buy the bottle of electrolyte, and you added electrolyte in the proportion 65-35, and you recover the battery properly. All right, be careful with that. Don't try to recover with pure water, because right now you change the proportion of water and acid. Important recommendation. Yes, don't forget this wonderful table. If the battery is 12 volts, 12.0, this is an indication that the battery is 50% discharged. Look at this, 11.75. 11.75, the battery is discharged 70%. It is a cranking battery. Probably you damage the battery. The cranking batteries never discharge those batteries under any condition below 50%, because the plates are thinner plates, and if you discharge more than 50%, the bottom of those thinner plates will be eroded, and that sand, that oxide of lead, produce a short in between the plates, and the battery will be out. Okay, this is not good. Each lead acid fluctuates, the voltage of the cells fluctuate in between 2.12 volts and 1.75 volts. When the battery is empty, is completely discharged, the voltage in each cell is around 1.75 volts. When the battery is fully charged, the voltage in each cell is around 2.12. Okay, important recommendation. And this is about the voltage. All right, 65%, 35%. The hydrometer is a good indicator to check the proportion of water and acid. Remember that depending on the proportion of water and acid in the electrolyte, you can predict if the battery is discharged or fully charged. This is a method used in the past to verify the condition of the electrolyte, the hydrometer. Okay, be careful with the hydrometer, because you spill a lot of electrolyte probably on your cloths. You damage your cloth, and it's not good. It's sulfuric acid. All right, but this is excellent because you introduce over there, you pump it, and you fill with electrolyte the plastic container. If the needle is in the green area, or blue one in this case, indicate that the battery is in good condition, because the voltage in each cell is around 2.2, and if the needle is in the middle, indicate that the battery should be recharged. If the needle indicate the red area, indicate that the level of charge in each cell is too low, and probably the battery is out. Okay, this is the hydrometer, and those are the readings. When the voltage in each cell is around 1.27, the battery is 100% charged. When the reading in each cell is around 1.11, 1.20, indicate that the battery is around 50% of charge. If the battery is 1.1 or less, the battery is completely out. Dead. Okay guys, now we are going to talk about some important concepts before we check the batteries. This is the information that we found in the label of the batteries. The information number one is amps per hour. Amps per hour. What is the meaning of amps per hour? If a battery is the capacity of a battery to supply 1 ampere per hour during 1 hour of constant load. We have an example here. Suppose that you have a battery with a capacity of 7 amps per hour, and the battery is specified for a current of 3.5 amps. That means that the battery can supply during 20 hours 3.5 amps constant. All right, because 70 amps per hour divided by 3.5 is 20. This is the amount of time that this battery is able to supply 3.5 amps. All right, this is a good example of amps per hour. In my opinion, the information related with amps per hour is the most important, because this is the number that you need to calculate to size the capacity of the panels, the solar panels, and also the capacity of the battery charger, the amps per hour. But not all the batteries, they have in the label that information about amps per hour. The majority of them, they have information about reserve capacity. And in my opinion, that information related with reserve capacity is not relevant. But the good news is that you can convert reserve capacity into amps per hour. You can convert reserve capacity to amps per hour. Basically, you need to multiply the reserve capacity times 0.4167. You multiply the reserve capacity, the number that you have in the label of the battery, RC, times 0.4167, and you have the amps per hour. And this is the information that you need. In general, if you have the information related with the reserve capacity, you can multiply times 0.5, and this is approximated the capacity of the battery in amps per hour, because that number 0.4167 is not easy to remember in the future. Okay, if you multiply the reserve capacity times 0.5, this is approximated the capacity of the battery in amps per hour. The new batteries, the lithium batteries, they have the information about the amps per hour big in front of the battery, because this is the most important information, not the reserve capacity. Okay, this is the second one. The number 3 is the state of the charge. This is another very important information for the new technology, the hybrid boat and the full electric boats. This is the amount of charge that you have actually in this battery. This is the amount of charge that you have in this moment in the battery bank. And this is very important. I'm going to explain later in other episodes, because my recommendation for hybrid boats is this. If the level of charge in the battery bank decreases 20-25%, it's necessary that the generator start, activate the battery charger, and recharge the battery bank. This is, in my opinion, the best equation for a hybrid boat. You can check that information in my book of the electric and solar boats, and also in the new course. In that course, I explain that situation and how to activate the generator automatically with the Victron intelligent smart system. Okay, the state of the charge indicates how much is the percentage of charge in the battery bank, or DOD. Yeah, this is the depth of the charge. DOD is a measure of how deeply the battery is discharged. When the battery is 100% full, the DOD is 0. And of course, if the battery is 100% empty, the DOD is 100%. All right, the DOD. And we are going to install a special ammeter connected with a shunt to show the capacity of the battery, the DOD of the battery. Now I am going to explain that process. As you can see in this moment, we have a group of batteries, 2 batteries of lithium, 48 volts, 96 amps per hour. The batteries are connected in parallel, positive with positive, negative with negative. And in this moment, the system is running, and I have in the display that the DOD of those batteries is 0, indicating that the battery is 100% charged. The batteries are fully charged, and the batteries are 48 volts. However, the voltage is 53.4, indicating that the batteries are fully charged. This is a Victron system that we are going to study later in other chapters, and this is part of the course of electric and hybrid boats. And in this moment, the group of batteries, 48 volts connected in parallel, around 200 amps, enter here into the smart shunt and the link distributor, indicating that the level of charge in the battery is 100%. The batteries are fully charged in both gauge. This is possible because we have installed here a shunt, and the shunt is the element used to convert the flow of energy over there into the DOD. Other important information is the CCA, the cold cranking amps. And I want that you remember that if you want to select in the future cranking batteries, the most important information in the label of the batteries is the CCA. What is the meaning of CCA? It's a critical good for cranking ability. It's the number of amps that a battery can support for 30 seconds at a temperature of 0 degrees Fahrenheit before the battery drops the bottom level. Okay, this is interesting. How much amps can supply that battery at 0 degrees Fahrenheit during 30 seconds. This is the CCA. All right, great. With that information, we can select the proper battery for that motor, for that engine. It's the CCA, especially in cranking batteries. The CCA is an important information. Okay, now with this information, we are going to try to check the batteries, and we are going to try to verify if the battery is in good condition or if the battery require more charge, or if the battery should be replaced. The element recommended to check the batteries is not the voltmeter. The element to check the batteries recommended is the load tester. This is an analog load tester. It's a cheap load tester. It's not expensive. You can buy one of those in any marine storage or automotive storage. This is used in both industries, the marine and automotive industry. Okay, we are going to check with this lead acid battery. This lead acid battery says in the label that the CCA is 650 CCA. Okay, this is the capacity. The battery is 12 volts. Is the series 27. Okay, we are going to check. When we check with this element, if the needle immediately I connect the positive and the negative of the battery stay in the green area, indicate that the battery is good. After that, we are going to apply a load during 10 seconds. If the needle stay in the green area, indicate that the charge of the battery and the battery is in good condition. If the needle immediately I connect the load tester stay in the yellow area, indicate that the battery is good, but the battery need more charge. All right. And if the needle immediately I connect the terminal stay in the red area, indicate that the battery is bad and the battery should be replaced. Okay, we are going to check this battery. This is the negative terminal, and this is the positive terminal. And right now we have in the green area the needle, and I am going to apply load, and the needle stay in the green area. That indicates that this battery is in good condition. That's simple. It's not complicated. This is a load tester because this element simulate a load and send a load to the battery. This one is good for lead acid batteries, but for more sophisticated batteries like lithium batteries and other modern batteries, this is not good because this element during the process, when you apply the load in this button, send the same charge. Doesn't matter if this battery is lithium or gel or lead acid, send the same load, and probably you can damage the batteries. In that case, the recommendation is if you are working in this industry, I recommend try to buy a digital load tester. It's excellent. You connect the positive and the negative on the battery, but this element asks some questions. The first question is if the battery is connected with the motor, with the system, or if the battery is isolated, if the alternator is running or not, and also asks to you about the CCA of the battery. And you introduce the CCA, and when you apply enter, this element sends the load, the proper load to protect the battery. And immediately you have the report, and the report says the battery is good but need more charge, or the battery is not good. And also the majority of those elements can be connected with the Bluetooth, and you can send the report to the customer, or you can print the report. I recommend try to keep one of those in your toolbox, because it's necessary, especially with the modern batteries, the lithium batteries. You need a good battery load tester. Okay, be careful, especially with lithium batteries. because in some lithium batteries you need a specific battery load tester. This one excellent for any other type of batteries, gel, lead acid, AGM. This is great because these elements send the proper CCA, the proper load according with each battery. I love it, this one. And this one is good for the majority of the lead acid batteries. You can keep both of them. I recommend both of them. This is the properly way to check the batteries. Okay, now we are going to do a simple exercise. Suppose that you receive a phone call related with the situation in a battery bank in a boat. The customer complained that the battery bank no accept a charge. The battery charger is running. However, the level of charge in the batteries is 80% or 70%. And when you turn off the battery charger, the level of charge goes down. Okay, you need to verify, number one, the wiring and the condition of the batteries. Okay, those are my recommendations when you have problems with battery banks. Number one, take a picture of the actual situation in the connection, the wiring of the battery bank. Number one, take a picture. Number two, try to understand how is the connection. What is the input, what is the output, what is the input and output positive and negative cables, and how is the configuration. Okay, this and this and this in series, and this in other series, and both of them connected in parallel. Oh, now I understand. And try to do a picture by yourself in a paper with different colors about the actual connection. If you understand the connection and you have the picture, you can pass to the step number 3. The step number 3 is isolate battery per battery. You remove the terminals in battery 1, and with the load tester you check the battery 1. Okay, battery 1 is good. Okay, you put in back the cable, you tie the cables, and you disconnect the second one. You check the second one, and after that the third one per one. Okay, in that process I found it that the battery number 5 is damaged and battery number 7 is damaged, both of them. Okay, what is the recommendation? The recommendation is replace the entire group. Replace all the batteries. If you receive the approval to replace the batteries, the next step is this. Check in internet if you find the same batteries today, the same specification, the same series of batteries, and the same capacity, and if you find the batteries with the terminal, with the bus in the same position than the original. Be careful with that. If not, the cables, you don't have room for the cables, and you have a big problem. Okay, and check the dimension of the batteries in internet about the new batteries. If the height is the same, the width is the same, and the length is the same. Be careful with that. Okay, if you are 100% sure that you can find the same batteries, the same series, with the same position on the terminals, order the new batteries. Okay, and when you receive the batteries, this is the process. If you have the picture, you have the diagram, you can disconnect the group of batteries carefully and mark with a blue tape and labels the cables. All right, and when you disconnect all the cables and you tie with the tie wraps the cables in one side, remove all the batteries, take a picture of the area once again without the cables, and after that remove the batteries. This is important. The picture is only to refresh the position of the terminals and the position of the batteries with respect one to the other one. After that, remove the batteries, clean the area, verify that the drains in the area are working. You have a good drains for water, and verify that the area is clean. Verify that the fans, because normally if you have a battery bank, you have fans. If the fans are working, the ventilation is good. And after that, remove battery per battery and introduce the, before you introduce the new one, clean the area, paint the area if it's necessary, and organize the area. And start to introduce the new ones one per one in the same position than the previous one. Okay, before you connect the cables, check the terminals of the cables. Verify if the cables are corroded on the terminals. If you found that some corroded terminals, and if you have room, cut it, that terminal, and crimped a new terminal with a new heat string. Verify that the cables are in grid condition. If when you cut it, the terminal, you found that the wires are green or black, this is an indication that the humidity penetrates the cable. My recommendation is replace the entire cable. All right, be careful cable by cable, check continuity, if it's possible, with the voltmeter or with the time domain reflectometer, the TDR, the time domain reflectometer. Check cable by cable, and after that, start the process to connect. My recommendation is, if you have a series connection, start with the series connection with the cross cables, and tie the cross cables and protect with rubber terminals the end of each cross cable. When you finish the series, connect the series in parallel with the other ones. This is my process. When you finish with that, verify with the voltmeter that the output voltage is exactly the voltage that you require. If not, it's because you connect something wrong. No connect the final cable, positive and negative, to the system before you verify the voltage. Verify the voltage, verify that everything is good, verify the switch selector, and after that supply power to the panel and verify that you have the proper voltage and the proper amps.